All right, lesson 11.2, we're going to take a look at box and whisker plots. Now to give you an idea what a box and whisker plot looks like, we have a visual of one right here. So this is a box and whisker plot, and if you're thinking where do they show up in real life, right now in the news there's tons of graphs showing up that maybe are less familiar to us because they're better displays of what the records and the research is trying to show. Here's a scenario that shows up over the course of time in stocks. People might have investments in stocks, and they're called candlestick charts. You can see how it kind of looks like a candle, and then it shows the growth of the stock or decline over time. So just an application of where it shows. But let's go ahead and make some. Okay, so first of all, just a brief summary about how a box and whisker plot is created. You're going to have a box. There's going to be a line somewhere in it, and then you have two whiskers out the sides. This lowest point is my lower extreme. That was written pretty poorly, sorry. And then this point up here is my upper extreme. So you can imagine my lower extreme is my lowest point, my upper extreme is my highest point. Now right here in the middle, if I consider that a point, if I put a point on it, that's my median. And then this point here is my lower quartile, making this point here my upper quartile. So these things that I just wrote in here are actually going to be represented with numbers. So one number is going to be used to create this value, to plot each of these points, and from there we can build our box and whisker plot around it. So what that is known as is a 5-number summary. Okay, and then it breaks our data into 4 quartiles, and it tells us kind of the spread of our data. So my first quartile is represented by this region right here. So this is considered like the first quartile. This region in here is my second quartile. This is my third. And this is my fourth in terms of my portions of my entire box and whisker plot. Okay. So, and they have all of that spelled out for us here. Now they use Q1 to represent this like lower extreme. The median here is Q2 and this is Q3 to represent that upper extreme. Okay, so that's our 5-number summary like we said. Now depending on how the data is displayed, it's going to be considered one of 3 different things. Symmetric is most easy to understand, and that's whenever, if you look at symmetric right here in the middle, it looks like everything is balanced. Okay, so the whiskers are about the same length, and the median is about the middle of the plot. So that's a symmetric one. Now whenever we look at this first one over here, this is considered skew left. Okay, so when the left whisker is longer than the right whisker, so my left whisker here is longer than that right whisker. So I think if I consider this is our cat skew. And my left whisker is longer, it's considered skew left. Okay. If my right, and what that means is that most of the data are on the right side. So it's skewed left, it's spread out here, but most of the data are comprised right here. With this second one, or my last one rather, my right whisker is the longest one, like we have here. So we still have our cat skew, and that right whisker is what's longest, and that means most of the data are congregated there on the left side. Okay, we'll talk about how to label those with an example. All right, so let's try some. Example 1 here, they'd like us to make a box and whisker plot representing this data. So what I've done is I put the numbers in order, and then I went through and I crossed them out to make sure I didn't miss any. So now they're all in order, and this is going to help me a lot. So I'm going to label my 5-number summary over here on the left. So lower extreme, lower quartile, median, upper quartile, upper extreme. Okay? So now the easiest ones to point out are the lower extreme and the upper extreme. This is my lower extreme, 4. My upper extreme is the highest number, 9. Okay. Now the median, let's find the middle. So there's 1, 2, 3, 4, 5, 6, 7, 8, 9 data numbers. That means my middle number here, right in the middle, there's 4 to the left and 4 to the right. So my median is 7. Now to find my lower quartile, we never count the median no matter what. So the median, once it's written down, is kind of out. Now I want to find the middle of this lower set of data. So of these 4 values, what's the middle? It's going to be right here. which is 5.5. Okay, so if a number doesn't show, then we just find the average of those two. Same here, the middle of these is going to be 8. Okay, and now I can go ahead and put this on a number line. So when you make your number line, it's good to have it space out about evenly. So I'm going to approximate these. I'm not pulling out a ruler, but it's a good idea to keep your data. Could even spread them out more, but that's okay. And I didn't even put 1, 2, 3, 4, 5, 6, 7, 8, 9. All right, so I'm going to plot my points. So my points, my lower extreme was 4, so I would put a point here. My upper extreme is 9. My median is 7. My lower quartile is 5.5, and my upper quartile is 8. Okay, now to create the box and whisker plot, I put a line through these middle 3, and that's my box, and then I extend these. And there's my whisker. Okay, whiskers. Now this one, it doesn't ask us, these are hours of sleep. It appears like it's a little bit more skewed, slightly skewed left. And that's because my whisker here on the left seems to be slightly longer. And if I actually look at it, that spans from 4 to 5.5, whereas that one only spanned 1. So yeah, this is skewed left. It's slightly longer on the left. That means it's skewed left. And so what that tells us is that more of the data is congregated on the right. Okay? All right, let's make another one just for some practice. So I went ahead and these are algebra test scores. I put them in order. I checked off to see that I had them all. Let's go ahead and make sure we have make our 5-number summary. So lower extreme, lower quartile, median, upper quartile, and upper extreme. My lower extreme is my smallest number, 63. My upper extreme is 96. My median is right here in the middle, it's 84. And then my lower quartile is the middle of these. So if you aren't sure what it is, you can go ahead and do 71 plus 76 and divide it by 2. You're really just finding the average of those. So that's what we get for that one. We're going to get 73.5. And then same deal here. We find the middle of this, and that one's a little bit more obvious, but if you did 88 plus 92 and divided it by 2, you're going to get 90. You're going to get 90. Okay, so I'm going to break these into, let's count by 5s maybe. How about 60, 65, 70, 75, 80, 85, 90, 95, 100. Okay? All right, plot in our numbers. We have 63 right about here, 73.5. Obviously a computer, if this was something super critical, would be a lot more accurate with these values. But we have our 5-number summary. I'm going to make each of these boxes. And then again, we have a skewed left. A longer whisker on the left, which means most of our data, and it's only slightly, but more of our data is congregated there towards the right. Okay, let's answer some questions. So this represents the prices of soccer balls at different sporting goods stores. Now I recognize you're not going to go ahead and make a box and whisker plot about soccer ball prices, but we're also not going to analyze climate temperatures over the course of the last century. That's a lot more intricate and involved and variable. So that's why they give us some generic scenarios like these. So anyways, find and interpret the range of the data. So the range, remember, is when we take the largest number minus the smallest number. So if I do 24.5 minus our 8.5, we're going to get 16. So the range of the data is 16. That means, since we're talking about soccer ball prices, there's a span of $16 from the cheapest to the most expensive soccer ball. The data, if I'm describing the distribution of the data, it slightly, not drastically. When I say drastic, I'm like if it was something like that, that'd be more drastic. But this one is slightly skewed right. Okay. And that is because my whisker over here on the right side is slightly longer. That spans 4 1/4, and this here only spans our 2 3/4, so it's a little bit different. Okay, just slightly more longer on the right, so more of the data is congregated on the left. Okay, alrighty, so find and interpret the inner quartile range. So I said we'd come back to that. this is our inner area, inner quartiles in between here. So my inner quartile range is basically the range of the box. So the way I would find that is I would do 20.25 minus 11.25. Okay, and that's just going to give me 9. So find and interpret the range of that data. If they want me to tell me, if they want us to tell them an interpretation there, we can say something like the inner values of the data span by $9. There's a $9 span within the inner quartile range, something like that. And then lastly, are they more spread out below quartile 1 or above quartile 3? So remember, this is quartile 1, this is quartile 2, this is quartile 3. So are the data more spread out below or above? Well, this below would be this much, and above would be this much. They're more spread out up here for the same reason this is considered skew right. So the answer is above quartile 3. And I would say that this has a larger span than that first whisker, and that's my reasoning. Okay? All right, let's turn the page. We only have a tiny bit more. Here we have a double box and whisker plot, so it's comparing the number of tornadoes for a month for 2 different states. So the shape of the distribution. So I'm going to say state A is about symmetric. It appears to be pretty symmetric. And then state B is definitely skewed right. That whisker on the right side is much longer than the one on the left. Next, which state's tornadoes are more spread out? Well, that's going to be state B. If I look at the range, it's about 27 minus 4, so it's 23, whereas the range of this state A is 14 minus 0, 14. So the range shows that state B, if I had to explain it, are more spread out. And I would explain that in words. I'm just not going to write it all out. And then part C, which state had the single least number of tornadoes in a month during the year? So what that is getting at is that they want to see which one had the least number. So we don't know all the numbers that fall between here. The only number we know for sure that existed were our lower extremes and our upper extremes. So state A had at the lowest end 0 tornadoes. State B had at the lowest end 4 tornadoes. So which state had the single least number? State A, based on our lower extreme. Okay? All right. I'm going to go ahead and turn this data, we only have 2 things left, turn this data from, this is a dot plot, we're going to turn it into points. So here we have 1, 2, 3, 0. So I'm going to write 0, 0, 0. We have 2 1s, 1, 1. We have 1, 2, 3, 4, 5, 6 2s. 1, 2, 3, 4, 5, 6. Then we have 3, 3. Then we have 1, 2, 3, 4, 5 4s. We have a 5, and we have an 8, not a 6. An 8. Okay, so we've taken the dot plot, turned it into data. So the nice thing with a dot plot is it tells you all the data. A box and whisker plot does not do that. So now I want to go ahead and make my 5-number summary. Median, upper quartile, and upper extreme. Okay, lower extreme is 0, upper extreme is 8. My middle here, I'm going to find the middle. So there's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20 numbers. So the middle is going to be 1, 2, 3, 4, 5, 6. It's going to fall right in the middle here. Now that we haven't seen one like this before. When the median doesn't exist, you just find the average of these 2 numbers. Now in this case it is just 2, but if they were different numbers you would find the average of them. All right, my lower quartile is the middle of these values, so it's going to fall right here, which is 1.5, and my upper quartile is the middle of these values, so it's going to be right here, which is 4. Okay, all right, so again we put these on a number line, and I'm going to have this ready for you right now. All right, so I'm back. I have the video, the box and whisker plot made. And so we can see here clearly that this is definitely skewed right. It's longer on the right, which we've been saying all along. That means that more of the data is congregated on the left. And when we look at our box and whisker plot compared to this dot plot, we can see that visually. The box and whisker plot doesn't tell us all these numbers. We don't get any of these numbers. We only get the lower extreme for sure and the upper, but it tells us how it's broken into quartiles. So 25% of the data falls in this range. 25% of the data fell in that range. this range, and this range. And we can see that because it's skewed right, most of our data is congregated on the left. And this here is number of customers in tables at a restaurant.